So, yeah. Pass it off to Marcelo.
Yeah, welcome everybody. It's great to have you visit our office. We just moved here in November, and we'll be here for a little bit longer until our new office gets ready across from the City Hall. This is the first Kotlin meetup that they're hosting, right?
Yeah.
There'll be a lot more, and yeah, it's great to have everybody here. Everybody's familiar with FAIR, like what we do? No? I'll talk a little bit about that and just to bring you guys up to speed. So FAIR, we are a relatively young company. We started in January 2017, so we just turned 2 years old now, and we went to Y Combinator, and we are a wholesale marketplace, so we help connect small retail shops to makers of products that they would sell in their stores. Similar to what Amazon does, basically, but instead of selling to consumers, we sell to stores. And yeah, we have been growing pretty quickly. And today we have about 28 engineers here. And we also have an office in San Francisco. The total, our company has about 80 people today. And yeah, that's what we do. And if you have any more questions, I'll be here after. You guys can talk to me.
There's a presentation on DSLs, and one of the biggest parts of DSLs is the Lambda with receiver, and I felt like I could go into a bit more depth on that today, and kind of talk about some of the other parts of Lambda with receivers. I'm going to do a quick bit of review on just Lambdas and Kotlin just to get everybody up to speed, but I'm kind of going to go through that very quickly. So yeah, performance provided by FAIR, we've already talked about that. We have a lot of our backend is using Kotlin right now, and yeah, our Gradle build scripts, and we're using it for our new Android app. Okay, so Lambdas. Lambdas are higher order functions. So it's the idea being you store a function, you can store a function as a variable, or you can pass a function as a parameter, or you can return a function from another function. And it's a basic requirement for any functional programming. So in Kotlin specifically, and Java really, it's mostly useful for anonymous functions. So you kind of pass a function inline as a parameter to another function. So in Kotlin, this is kind of what a lambda is defined as. So you have, if we wanted to represent it with a variable. So you have the variable name. That's the lambda definition or function family. So it's saying that it takes an int and it returns an int. And then there's the definition. So here's the input, so your int, and then your output. So this one would increment. And so if we put in 5, we get 6. Okay, so I'm going to talk a little bit about Java Lambdas and then Kotlin Lambdas just to kind of explain there actually is some differences. Not just in terms of performance, but functionality, what you can do with them. So, Java Lambdas were kind of tacked onto the Java system in terms of a single abstract method. So the idea is you construct a new instance of an anonymous object every time you use your Lambda, and it executes the function inside. It can only access what variables that are effectively final, so it can't mutate any variables outside of its scope. It doesn't introduce a new level of scope. So its scope is actually considered the same as its surrounding scope, which means it can't do things like shadow variable names. Not that that's necessarily good practice, but it can't do that. You won't get an error if you try defining a variable with the same name. You can't throw checked exceptions in a Java Lambda, which this is actually kind of a big limitation, especially since, most Java libraries, their library code throw checked exceptions. So you have to do something ugly like wrap like the Java library code with your own code that turns it into an unchecked exception. And then even if it does get thrown, the stack trace is very hard to follow. And you can't use, the way they're defined, they have the return keyword to return a value. And that's significant when we talk about Kotlin Lambdas because there's a major difference there. But so Java Lambdas actually use the return keyword. Or they can be defined in one line, in which case they don't. So, yep.
Would you mind explaining what effectively final is?
Yeah, okay. I'm about to do it right here. So, here's an example of some Java code where we're using Lambdas. So the consumer here is a Lambda. I have a method here that takes an integer. Now, I can't mutate that integer at all, because if I do, it's not considered effectively final anymore. So basically, if the variable can be mutated inside that scope, it's not effectively final.
Like, how is that different from just final?
Good question. Basically, what the compiler does is it determines, could this be final? And if it could have been final, then it won't allow it to be used in the Lambda. So that's why effectively final. Like, you could mark it final and it wouldn't cause a compiler, is basically the idea.
So you're saying if JVM marked it as final during the optimization, then it's effectively final?
So if it could be marked as final, yeah. Like if you decided to put in final, I'm not sure if the compiler actually does mark things as final or not. No, it doesn't. Okay. But yeah, like if it could have been marked as final without a compiler effectively, then that makes it effectively final.
So it can have access to X because it's not modified. But let's say I do X outside the Lambda scope, just outside Lambda scope, then will I have access to it?
So if I try to assign X here, I can't do that.
Sorry.
Yeah. So basically, if it's mutated anywhere, then not allowed. Also not allowed to define X here because to shadow that X, for instance, because this is actually the same scope. So that's just some of the way, like, that's Java Lambdas. Okay. So let's talk about how Kotlin Lambdas are a little bit.
So
Yeah.
you have an inner class there.
Yeah, I made an inner class. I actually took this example off of Oracle's Lambda example. And I kind of trimmed it down a little bit, but they basically wanted to show that you can shadow the int here, right? So you have the outer class. This inner class can shadow the int from Lambda scope test with the int here, but you can't shadow it here.
Oh, I see.
So they're basically showing that and also this one shadows that one. So this shadows that one, this shadows that one, but you cannot shadow inside the Lambda because it is in the same scope. Okay, so Kotlin Lambdas, some major differences. They can be inline. So what that means is when it compiles, it actually, the compiler will first inline the code and then run the compile. And JetBrains provide enough tools that if you're, especially, I'm not sure if it's just IDE, but if you're doing debugging in IDE, it's very easy to follow. Like, I've never had a problem with that. So it is in a new scope, and the scope is a closure. So what that means is you can mutate variables that come in your scope. You have access to the outer scope as if you were, like it's an enclosed scope, similar to how a class encloses functions. And the major difference here, so the last expression result is the implicit return value. So you don't have to use the return keyword. In fact, I'd say it's probably bad style most of the time as you get used to Kotlin to actually use the return keyword from a Lambda, unless you want to return from the outer function, which is what, so you can return from the Lambda by doing return at function, the Lambda function name, to exit your local Lambda, like return from it. I'd say that's bad practice as you get used to Kotlin. But you can return directly from the function. I'll show you that in a second. But you can return from your outer function that has the Lambda inside it from an inlined Lambda. So the advantage there being, let's see if I have a good example. I'll get to that later. But yeah, you can return from a Lambda that's inline. Okay, so just showing, I want to breeze through this quickly, but so for scoping, you can see that here I'm able to access the X from this. This is basically a copy of the Java example. I'm able to access and mutate the X from out here. And if I wanted to, I could even, qualifying it, access this X if I wanted to, because it's all within the closure. So some other nice little syntax features you get from Kotlin Lambdas. If it's a single parameter one, you can just reference it, the parameter as it. It's just implicitly there. If you want an unused parameter, you have an underscore. You can use underscores as a marker, which is also a best practice to do that anyways. If the last parameter of the function is a lambda, you can actually move the parameter outside of parentheses. I'll show that in a sec, and it creates really nice looking code. And the inlining for non-local returns, that's what I was just talking about a second ago. I have an example in a minute. Okay, so here's an example of the implicit it. So I have a list of ints, I'm trying to filter them. I can just do it is greater than 0. So give me all the ints greater than 0. I don't have to actually give a name to the int being filtered, the parameter. So underscores in place of unused parameters. In this case, not strictly necessary, because just before we saw that if it's a single parameter, you don't actually have to supply it. You can just say it. But it's best practice, even if you're even if it is a single parameter, to put that underscore just to make it very clear I'm not using the parameter at all. If the last parameter is the function is a lambda, you can move it outside the parentheses. So this function takes 2 parameters. The first one, or it gets 3 parameters, right? I have file name, threads, and then the third parameter is actually the lambda here. So it actually creates sort of like a, it almost looks like a language construct. And it becomes very natural to work with. So run application, here are the static parameters, here's the dynamic code that's going to run inside that function I call. And inlining, okay, here's my example. So you can see here, I want to have so I have an inline function. It takes a lambda. The lambda has no arguments and returns unit, which is basically void. It's a singleton that represents no return. So my example here is I'm going to print A, run whatever code you've supplied me in the lambda, print B, return 0. So when I call it the first time, I'm calling my function test with true. What will happen is, because it's inlined, this code's going to val x equals print A, if true, return 1, print B, return x. So what happens is it will immediately return because the condition's true. Now, the thing is, the great thing about that is, so this is a lambda, but the return keyword means the same thing no matter where I am. It means I'm returning from this function test, even though it's inside a lambda. So Java can be a bit confusing in these types of situations, because with Java, return just means return from the lambda. Here, return always means return from the function I'm in. So I got a little, so it's a non-local return. And so if you want to know, this code will print A, and then AB. Yeah. Oh, I guess it's also printing that. So A1, A0, or AB0. Yeah.
It's printing what's returned.
Yeah. Okay. So Any questions? Because I wanted to whip right through Lambda stuff. Sure.
How do you return from the Lambda not the function?
So you're wondering.
I just want to return from the Lambda.
Ah, yes. So if I want to do an early exit, that is why there's the return at. So what I could do is return at non-local return, and it would return up here. Now, and so keep in mind, like when this runs the first time, this code's never executed, right? Because it's returning right here. It's returning from this function. So if I use return at, then it would fill in x with the value, and then it would return 1. So it would basically do the same thing, but that is how you return directly from the Lambda. So that's you do that only in the cases of early exits from a Lambda. Really, most of the time, what you want to do is you want to just have the last expression be your return value of your Lambda. So whatever the last expression evaluates to, that's the return value. Cool. Any other questions?
So you said it's bad practice in most cases to have an at return. So if you have multiple points of exit, would you say it's better to rewrite that method? That's not bad practice.
Yeah, that's actually kind of, I would say if you can refactor your code in such a way that it shortens the way the Lambda's working. Odds are if you're doing lots of early exits from a Lambda, you probably need to refactor your code. Like you probably need to decompose it into different methods. And so, but maybe not. Like there are cases where you'll want to use the early exit for return at. And I think that's really the only legitimate use case for the return at.
Can I add?
Yeah, sure.
The way I typically handle these is I extract the whole body of the Lambda as a function. And then that's a regular function, so I can do like early returns and stuff. And then in the Lambda, I just call the function with parts.
Wouldn't you rather have a reference to the function directly though? Like if you have a Lambda that's just calling a function, that already, like the function reference.
Yeah, you could do that too. Yeah.
Yeah. Okay. Cool. Okay, so now the actual topic of the day, receivers. So this is a language feature that's specific to Kotlin. I don't know of other languages that use it. It was very new to me at least. So it is just syntax sugar like most things in Kotlin. It doesn't enable necessarily, Lambdas actually enable some new capabilities that Java can't do. This doesn't enable capabilities necessarily that Java can't do, but it does make it a lot easier to work with. And these are kind of, so a way to think about them, the easiest way to think about them is we have extension functions in Kotlin, so you can extend any class with a new function. These are kind of the first-class citizen equivalents. So just like you can pass lambdas around as a first-class citizen of a regular function, these are the first-class citizen equivalents for extension functions. So we've got an example here. So I've got my function here, and this is the lambda with receiver definition. So the first thing to note is that's how a lambda with receiver is defined. So it's got a class name dot and then the lambda function family. So it's saying this is a lambda that operates within the context of this object. So what that means is the definition, A is the receiver type. So when we're saying lambda with receiver, A, this class A, is the receiver. And so what happens with the receiver is that when you have this lambda, the receiver modifies the interpretation of the term this inside the lambda block. So you can see here, my IDE has helpfully noted that this has become A. the type A. So now I have access to this printFizz function, and if I call this dot, like explicitly if I want to, I can print buzz, like I don't need to have this there, just like anywhere else in code. So it basically gave me some additional capabilities for this. And I do say additional because it modifies what this is. It doesn't shadow it. That's pretty important. So it basically adds on everything A can do. But if I had functions available in the scope for this, I could also use those.
Where do you instance the class A?
So, sorry, where do I instance?
Well, I mean, you.
Okay.
So this becomes a reference to an object of class A.
Yep.
So where does class A get created?
In this case, there definitely needs to be an A, right?
Yeah.
In this case, what I'm doing is, so my function takes a lambda with receiver, so it takes this lambda.
Yeah.
I actually construct a new A right there.
Okay. And you call the.
And then I can do A dot call this lambda. Right? Okay. So this lambda, this parameter, right?
Yep.
Represents this code block.
Yep.
And so, and because the receiver type is A, it can call any lambdas that, or functions A that is in the class of A. So this instance of A can now call this function that's passed in.
Okay.
So let's say you have class A, and then you have class B that inherits from A.
Yep.
And then you do, but my function still uses the receiver A. But inside A, you create a val B equals B. And then you do B dot lambda with receiver. Will you get the scope of B, or do you only have the scope for A?
You only have the scope for A.
It's using a real B instance, but it's like working off of interfaces. You only see what the interface defines.
Yeah. So yeah, like what I'm saying here is, like as you can see right here, it's saying my this has been modified to give me everything A has. So even if I made like val B equals like new B basically, even though it actually is a B and not an A, it will only in here I only have access to what A has.
What would I call the implementation of B? What would it call the B?
It would call the implementation of B. Yeah. Yeah, I see what you're saying. So like if I override printFizz in B, yes, it would call B's. Okay, so yeah. Great little meme here. But why? Why even bother doing this, right? Because that actually was a question I asked a lot when I first saw this feature. Is like, what's really the purpose of this? Normal lambdas already solve a lot of this. Is it really worthwhile? So the major use cases for it are type-safe builders and DSLs. That's probably where you'll see it the most. You can also wrap object usage with certain actions. This is kind of the library usage provided by Kotlin, which I'm going to go through. Anonymous extension functions that you can pass around. So this is if you want to do higher order like functions with extension functions, and you want to do like really crazy functional programming. I have no use for this because it's a little bit beyond what I want to do. But maybe somebody who loves Haskell would absolutely love that feature. I don't know. And you can also, if you want, you can use it as a way to completely hide an implementation from the usage. So basically, inside your Lambda with receiver, you basically create the object, just like I did back here, right? Like I create my A. Well, suppose A wasn't actually an interface, and I create a real instance. Now here, it only this code can only ever see the interface, but the actual implementation might be private, and so I can hide the implementation completely. You can do that with regular lambdas, by the way. It's just another way of doing it. Okay, so library functions that are lambda, that take receivers. So apply, run, and with. So if you're writing Kotlin a lot, even if you never actually create your own lambda with receiver, you're going to be using these. And you should use these because they're great functions. So here's I put the definitions for with and apply. I can't remember if I added one later, but the main idea is they are a little complicated in their definition, but basically with, the idea for that is given a receiver object, it executes a lambda and then returns the results of that lambda. Apply, given a receiver object, execute the results of a lambda. Apply is also an extension function, so it's like, I'll show usage in a sec, but you basically execute the results and then you return yourself back. So, sorry?
I'm not sure you already answered it, but in this scope, in Lambda, what is your access? What is your access level?
Public. That's actually a great question. Yeah, you only have, I mean, you have access to internal scope if you're within the same module, but effectively you have, like, whatever access you would have from an external standpoint.
So you don't break configuration, you don't break encapsulation.
Correct. Yeah. Think of it. In fact, it actually is under the hood a static function. So it is not actually truly a member of the class. So the concept of this is still only from an outside standpoint, similar to extension functions, which are the same. Okay. So I just wanted to highlight. So this one takes some type, returns a unit. This one takes some type, returns something else. And they're both, so the receiver type is T here for both of them. I'll give a more concrete example in a second though. And so this one actually takes the receiver in as a parameter, and then it runs the lambda with receiver directly. So that's what with does. Apply is run, you use the receiver object instance, and then you call .apply. So it's an extension function. So let's talk about some best practices with apply. So it's useful for initializing objects to avoid repeating the variable name. So everybody's done this before where you like, I have an example with the Jframe in a second, where basically you create an object and you like go set size, set boundaries, set exit condition, you know, all these like different initialization stuff, and you have to keep repeating the variable name over and over. Apply is good for replacing that pattern, so you just kind of condense your code a bit. You're saying apply all these changes. Or when you want to take several actions on an object, then return it. But the main idea to think about when using apply is just, I want to apply these changes to this object, and that's how you should use it. And don't nest applies, don't nest with, because it adds on to the scope of this. So you start nesting them, and you get your this starts becoming very confusing. So here's my Jframe example. So I took some Kotlin code. I started off just making a simple Jframe. So you can see I have a Jframe. I call Jframe set size, Jframe set default close, Jframe is visible. So I keep repeating the variable Jframe. And apply allows you to, basically it says, okay, take your Jframe, make it the receiver of this lambda, and now that it's the receiver, it is this. So because you have access to this, it's this dot set size, or get rid of the this dot. So you just set size, set default close operation is visible. So it's great for initialization code. I got rid of all those dots. It's nice and clean. In fact, I don't even need a variable anymore to run my program. So best practices with the width. So this is for when you're repeating a variable name more than a couple times, basically. If you find yourself like doing a lot of things with an object, thus the name, it's useful to use with. So you use it when your object is being used in operations, not necessarily when it's taking actions. So you're doing things on the object, or the object's being provided as to functions. That's when with is good. And it does return the results of the Lambda. I feel like that's almost a mistake, because it's really confusing. Like, it's with this object, do all these things. Oh yeah, now it's mapped to a totally different type. That was the last expression. So I would suggest, as a best practice, don't use the result. I feel like it's more confusing doing that. Again, don't nest, because this scope gets confusing. Okay, so I have my class Spider-Man, and it has a function great responsibility. And I created a variable called great power, which is a Spider-Man. And just for this, I was able to say, with great power, do great responsibility. That's actually a terrible usage, though, because I'm not actually calling multiple things. I just did it specifically for this joke. Here's a better example. And this actually came from a recent code review, and I was talking with Dan about it. Kind of best practices on asserting. So I have this test object, and I want to validate a ton of stuff on it. So you can see here I have assert equals, so I'm testing Andrew equals Andrew.name. 32 is Andrew.age. 9001 is my score, right? But I keep referencing Andrew. Whereas instead, if I want to validate the full test object, it's much nicer to say, with Andrew, name, Andrew is the name, 32 is the age, 9001 score. So it just cleans everything up nicely. Okay, last library function, run. So you use this when you have an object that is taking actions. It's also useful if you have a nullable object that maybe you want to take actions. So this object, if it exists, do these things with it. This is the one I would suggest using if you want to transform. So given this object, compose a new object out of it using some of its functions, and then the result of the run is is your new object. So basically the way to think about this one, with this object, execute these actions. Again, don't nest. So here I have an example of using run. So I have an amazing plan, and it has like a bunch of functions that actually do things, right? So run is useful here because I'm saying I can actually execute the different steps. And maybe this profit function returns a plan execution result, so I can grab that. Now I've sort of done all these things, and I can look at the result. So this is, I just wanted a second example. Here's an example of this conditional, right? Maybe I have an amazing plan, maybe I don't, right? So in this case, I conditionally run using the null safe operator. So this is just one of those nice advantages of run, is that you can say, well, if it does exist, I want to run this amazing plan. Otherwise, don't do anything. So here's another library example of Lambdas with receivers, build string. So people in Java will often use like a string builder and append. The nice thing here is, so this is the definition for it. It's basically creates a new string builder, applies all the Lambda with receiver actions. So anything a string builder can do, you put inside your Lambda, and then it just toStrings it. Because, let's face it, every time you use a string builder, these two steps are things you always do. You always create a string builder, and you always toString it at the end. So this is a nice way to encapsulate that pattern. So here's an example: build string, append a, and 12. So, and then if I wanted to, the results is going to be a string that's been built. So I was looking up open source projects on how they use Lambdas with Receiver. Pretty much all of them right now are DSLs or configuration objects. That's not to say that they can't be taking advantage of other use cases, but I think it's underused because it's tricky to understand, which is why I thought it would be a good idea to do this presentation, even though we already covered it in DSLs. And so it's tricky to understand, so you might be nervous about how to use it correctly. I'm hoping some of what I've talked about today can help you guys understand that, like how to use it effectively. Outside of just DSLs, which are pretty straightforward as far as a usage for it. I think the big one to really consider is stuff like build string, where you have this pattern of something you always do, and the builder type object really it always follows this sort of pattern. Why not encapsulate it into some sort of Lambda with Receiver? So the opportunities I see, any boilerplate type code. So I was just kind of doing some brainstorming. In fact, I did this before at a previous company. So connection and prepared statements, creating a Lambda with Receiver for them. I did this one as well, temp file creation. So create like a Lambda with Receiver that gives you the temp file, and then it manages the cleanup of the temp file. And specifically in my case, it was on a server application, and because the way temp files in Java work is that they persist until the JVM exits, I actually wanted to clean up the temp file manually, not wait until the JVM exits, because the server could be on forever. So it kind of encapsulated that nice usage of make sure to actually delete the temp file, or actually queued it up into some service that called them. I just want to this is kind of the end of my presentation, leave off with start thinking, think about any other good candidates for where you could use Lambdas with receivers in your code base, or areas in a Java code base that you think could really benefit from it. And I think that would be kind of a cool talking point during the rest of our meetup.
So I've got prizes for the first 3 people that talk about some ideas of how you might use Lambdas with receivers yourselves.
Specific examples for maybe. Yeah, sure.
So in an application that we're working on, we've got a ton of forms, and they're very much just here's an input, here's a checkbox, blah blah. And so we built some factories around that. But starting the forms, it's always very much the same thing. Initialize the form in a particular way, add in these rows, and then dump the output of the form. So it's almost identical to your string builder example.
Yeah, exactly.
Thank you.
Yeah, that's awesome.
There's actually, it's not in my code, it's a standard library, but it's like a good dramatic version of Java's smart closables, which in Java is like a language feature, but here it's just like a Lambda. So it executes the block on a certain closable object and then just calls close. So you can do like closable.use, whatever actually will close it for you.
Yeah, I actually use that one a lot. I use use. Yeah, that's a good point. That's another example of a Kotlin library function. That's great. And actually, an interesting thing to note with that is you can kind of follow that sort of pattern I've done before with any kind of limited resource that maybe isn't necessarily closable, but is something that requires cleanup, and you want to make sure that it only exists inside a certain scope. That can be a really powerful tool.
So Kyle, where would you use DSLs?
You can have this back.
No. Some examples of that.
Someone else can answer.
Yeah.
For Gradle scripts?
Yeah, we use the Kotlin Dsl for Gradle script as well here.
Yeah, it's nifty. It's one nice thing about DSLs, which I mean is kind of a separate topic, but is discoverability, right? Your IDE allows you to, because the scope of this changes, your IDE kind of gives you hints about what you can actually do within that scope, and that's actually really powerful. That's kind of why DSLs are a really useful tool.
I have a question. With receivers, can you override already existing functions?
I'm guessing no, but
What do you mean by that?
Let's say there's like an integer, there's like a box integer, and another toString method for that class. Can I write a receiver for the integer class with another toString, another my own implementation toString?
so keep in mind, receivers, they're lambdas, so they're anonymous, right? Like, they aren't overriding anything specific. They're actually adding a new function anonymously to that class, right? But if you're thinking extension functions, which are not anonymous, they're statically defined. Yeah, so static functions, they cannot
So
override, right?
no, so if you have an extension function that is the same signature as a regular member function, so if you have like, let's say hello in the class, and then you have an extension function on that same type of object on person.sayHello, then when you call it, the extension function is never used. So the member function takes precedence. Similarly, if you have your Lambda with receiver parameter name equal to a method name in that class, then I would expect the method to take precedence.
Oh yeah, that's a good point. Yeah, you could call the variable name the same as the method.
Yeah.
I haven't tested that, but yeah, it is. Well, actually, I'd assume the Lambda with a receiver would take precedence because it's in scope.
Let's test it.
We should test it.
Yeah.
I think that would be fun. Okay. Yeah, so that's it for me. Feel free to ask me questions afterwards.
So if it's a new static method, then shouldn't it just not compile? I mean, like in Java, you can't have like a static method with the same name as the member function.
So
This is tricky though, right? Because it's a lambda, right? So it's a variable that.
But
You're right though.
I'm
It is a
talking
new
about
static.
extension function.
Yeah.
So compiles because it's in a different file. And in Kotlin, you define your class, but really
It's in like .kt. Yeah, the
Yeah.
file name kt dot class is
Yeah.
effectively a class. Yeah.
But like if you convert it back to Java, that would work.
So let's say you have a Kotlin file named like person.kt, and inside of that file you have person class, and then inside of that file, but outside of the class, you have an extension function person.sayHello, and then you also have sayHello inside of the class. When you compile that, you're going to see a person class created and also person KT.
Oh, I see.
Cool. So yeah, let's mingle. Yeah, and maybe topic of the day, lambdas with receivers. So I think it would be cool if everybody chats about their projects, maybe what kind of things they could use. Yeah. So cool. Thanks.